All right, now we're going to be a little more restrictive in our power function. So we're going to have f of x equals k x to the n, where, let's see, where n is a whole number. Okay, so we're not going to have fractions for exponents, or we're not going to have negative numbers as exponents. N is going to be a whole number. Now, if you were to graph x squared, that function, we've done that before, right? And so it looks like our parabola, oops, something like that. If you were to graph x to the fourth, it would have a similar shape, but it'd be a little bit flatter this way. And the same thing if you were to do x to the sixth, it would just be a little bit flatter around the origin. Now, not quite as dramatic as I have drawn here, but that's the idea. It kind of flattens out around the origin. And if you wanted to see graphs, you could go to Desmos. It's a free website. You can just go and put them in, or a graphing utility. Okay, it's Desmos. Desmos, yeah, that's D-E-S-O-M-S. Okay, if we were to graph x cubed, that one we've done before, something like that. And then if we graphed x to the fifth, it would be the same thing, but again, it flattens out a little bit around the origin. Or if you had x to the seventh, again, it kind of flattens out a little bit. So I don't have them drawn very well, but you could draw those, or they're pictured in the book as well. Okay, so we're going to talk about what's called end behavior, how the functions are moving on the ends. Like, which way are they going? Are they going toward infinity? Are they going toward negative infinity? That's what we're talking about when we talk about end behavior. So what I want to talk about is the notation now. When we say, let's look at this, oops, sorry about that. Let's look at this little graph, just the basic parabola, we're going to say. I don't have it drawn very well. Okay, sorry about that. All right. So let's say it's the x squared function, and you see those arrows on the end. Then we're going to say as x goes toward infinity, so as my x value is going this way, my input's going this way toward infinity, my output is going up and up and up. So we can say f of x is going toward infinity, or we say approaches infinity. So this is how we write this idea. As x approaches infinity, f of x approaches infinity. All right, now let's look at the other side. What if x is going this way? So we say as x approaches negative infinity, f of x approaches, well, it's going up, right? So x approaches infinity. All right? Now let's look at the x cubed curve, something like that. We would say as x approaches infinity, so x is moving this way, as x approaches infinity, f of x is also approaching infinity. See, it's going up, right? But what happens when we're going in the other direction? As x approaches negative infinity, oops, negative infinity, f of x is going down, 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 right? X is approaching negative infinity. So I want you to be familiar with that notation. Okay, I need a little bit more room. Okay, so I got us some more room. And now we're going to look at a chart that's going to help us know end behavior. Now, in your power function that we're working with, you're going to have a k, then the variable, and then the n. Okay, and remember n is going to be, we can say n is greater than 0. That's fine. Okay, so here comes our chart. kind of a 3x3 chart. And it's based on two things. One, if n is even, meaning n is an even number. So just like your parabola is an even number, it's going to follow that far end behavior like a parabola. Now, you may have something going on in the middle here, but that's not what we're talking about. We're talking about the far ends. So it's called far end behavior or end behavior. And so if n is even, then both of them are going up if k is greater than 0. So if k is positive, you get that kind of parabola, right? K is greater than 0. You get a right side up parabola, n is even. That means the end behavior is going this way. Now, a lot of textbooks will just show you the arrows. You can picture like a touchdown, like the referee putting both arms up like it's a touchdown. Okay. Now, what happens if k is negative? Well, if k is negative, then it's going to be an upside down parabola, right? If k is less than 0, it's going to reflect about the x-axis. So if k is less than 0, then both are going to go down. Okay? So picture like the umpire in baseball going safe. Okay. If that helps. All right. Now we have to look about, well, what if n is not even? What if n is odd? Well, then we're going to look at that cubic curve like that. We're going to say f of x equals k x to the n, but n is odd. Well, then it's going to mimic the cubic curve. Something different might be happening in the middle, but the ends are going to do the same thing. So if k is positive, then you're going to have one going up to the right, and then the other one's going down to the left, okay? So picture yourself like John Travolta dancing at the disco. You know, one arm up, one arm down. Okay. And I guess he's right-handed. Okay, now, if k is negative, if k is less than 0, then it's going to go the other way. It's going to flip like it's reflecting about the x-axis. So it's going to go up to the left and down to the right. Okay? If you use this little chart, it might be helpful for you to figure out what we call end behavior. Okay, so they have an example here. Describe the end behavior of the graph 1x to the 8. Well, k is greater than 0 because it's 1. K equals 1, and that's bigger than 0. And its n is even because n is 8. So it's like a parabola, meaning it's going to go up this way and up this way. Now, if we want to use the notation, we would say as n approaches infinity, as x approaches infinity, f of x approaches infinity. Not equals, approaches. And as x approaches negative infinity, f of x also approaches infinity. So you could write it that way with the notation. Some books will let you just do this. Some books want the notation. So I don't really care, but I wanted to show you both. Okay, now let's look at the next one here. Describe the end behavior. So you've got k equaling negative 1. So k is less than 0. And then you've got n is 9. So n is odd. So that's going to be this case here. That's going to look like that. And so as x approaches, we can do infinity first. It doesn't matter really which one you put first. As x approaches infinity, f of x approaches negative infinity. And as x approaches negative infinity, f of x approaches infinity. Now let me draw this out so you can see it. As x is getting larger, it's going down. That's this part. As x approaches infinity, f of x approaches negative infinity. And then as x approaches negative infinity, f of x is going up. So that's this part. Okay? And then if you were just doing arrows, you could say it goes up. Well, usually they do like a little curve arrow. It goes up to the left and down to the right. Sometimes I'll just type words up to the left and down to the right.